Yes. Okay. Thank you, Priyank and Abhi. Okay. So we were discussing regarding the WS security specification, and that ensures the security requirement, or that fulfills the security requirement of service-oriented applications. And we were looking at the requirements of security. So first you need is identification. That is, you have to uh, provide a claim, right, that I belong to a valid requester, right? So that is the process of identity. Then comes authentication. So the provider service has to identify whether the requester is a valid requester or not, right? That can be identified using, again, a few SOAP headers. We will see that what that SOAP header is called. Then third is authorization. Authorization ensures that what requester is allowed to access, right? So that you can check against your database and you can determine what this kind of requester should be able to access. Confidentiality and integrity is regarding the encryption. So that we'll study in brief, right? So let us start with the first one. So always we have two services, right? A requester and a provider, or you can say a sender and a recipient. So if you look at the figure, you can understand what identification is, right? Recipient would always like to know who are you, right? And by default, we are having loosely coupled communication, right? So where this information will be embedded? Will you be writing that information in the sender service or in the SOAP message? Yes, it has to be there in the SOAP message, right? So we need to have a standard header in the SOAP again. So yes, we have seen a lot of headers, right? We have seen MI headers, we have seen the endpoint references, right? We have seen headers related to reliability, right? Similarly, there are a few headers available for security purpose, right? So for a requester to access a secured service provider, right, it is not always necessary that your provider will be having the authentication and authorization, right? Sometimes it is an open service, right? So anybody can connect and access the, you can say, details like a weather service, right? But sometimes whenever there is a B2B communication, right, authentication is a mandatory aspect, right? So in that case, the SOAP message has to contain something, right, that signifies that the message is coming from a valid sender. Okay. And you can say that sender is making a claim that I belong to so and so company, right? Sender is making a claim so that it can identify that you belong to a specific company. So this process is called making a claim. Are you clear with this example? What is given in this slide? Right? Recipient would like to know who are you, right? And that information has to be there in the SOAP message, right? Okay. So claims are represented by identification information and it is stored in SOAP header. Okay. And this is ensured by WS security by providing a header that is known as token header, right? This, I think, is covered in chapter number 17 or 18 of our textbook, right? So if you are interested regarding the implementation and the XML part of this concept, you can just refer to the textbook for further chapters, right? So token is a special header that inserts the identification information, right? Again, I'll repeat. Sender has to make a claim that the message is from a valid requester, fine. And for making a claim, we need to insert a special header, and that is known as token. Is that fine? That concept? So token is a header block, right, which is supposed to be inserted in the SOAP message. Clear with this much? Right? Okay. Suppose as a provider, once you receive the SOAP message and you look at the token, right? So is only token sufficient? Suppose if the token is saying that I am a message coming from TLS purchase order service. Right? I am a message coming from TLS organization and purchase order service. Will that be sufficient? So only having the organization name is sufficient or not? What do you think? No, right? So making a claim is just, you can say, incomplete sequence, right? So identification itself does not ensure or does not guarantee that you can actually prove that it is a valid sender, right? So we require the second step, and that is called as authentication, right? So let us look at the figure that is going to make you more clear. Recipient is asking that how do I know you are who you say you are, right? I hope you understand this statement, right? Is that clear? Sender is saying that I am this person, right? So what recipient is asking that, do you have any proof, right? So that kind of process is called authentication, right? So let us look at the definition. Authentication requires that a message being delivered to a recipient proves that the message is in fact from the actual sender. Okay. So what we require is, within the token header itself, we have to provide some proof of identity, right? Within the token header, you require some proof of identity. So what can be the simplest thing that you can embed that will prove that you are a valid requester? What do you think? Should be the basic information that you can provide. Remember, right? It is a loosely coupled framework. So we never know the requesters in advance, right? That is the challenge. You never know the requester or provider in advance. You have to search and then explore. Okay. If it was a client server architecture, then this is not required. But in case of SOA, this kind of mechanism is required. So suppose if it is TLS, right, or purchase order service sending this message, fine. So what you would embed with the token header as a proof? Yes, as a programmer, what is your idea? What would be sufficient? ID, yes. Or you can say some kind of email ID as well, so that the provider service can contact on that, right? Some unique identifier you can share, that is also possible. And the bare minimum thing is you can provide the URL of the service provider, requester entity, right? From where this message is originating, right? So that the provider at least can look into that website and find out whether this is a legal, or you can say legitimate sender or not. Are you getting this point, right? So we require to embed a minimum information, right, with the token, and that is called proof of identity, right? So if I say that, if you provide claim plus proof, will that be sufficient to claim that you are a valid requester? Yes, right? So only making a claim is not sufficient. That's what you should be clear. You have to provide a proof in sense of either a URL or a unique ID or some, you can say, email address, right? Or even contact number, fine? So that is called authentication, right? So authentication will be performed by recipient, or you can say provider service. Is that true or false? Authentication process will be done by the provider service, right? Agreed? Okay. So we have seen two requirements: identification, authentication. I hope you are clear with the difference. Identification just says that we are making a claim by inserting the token header in the SOAP message. But authentication adds to that we add proof as well, right? Okay. Once the sender is authenticated, now we have another task in hand. What is that task? Once we know that the request is coming from a valid vendor or valid sender, sorry, then what is the next task we have to perform as a provider service? Are we going to expose all our services to that requester? No, obviously not, right? So ideally, you have some kind of authorization architecture, right? Yes, that's correct. Give access as per authorization. So you check what kind of requirement that requester is having, and based on that, you provide access to only few services or only to the requested one. Yes, requested one, as Urjit has written, right? Because if we expose everything, then again there can be security issues. Okay, so that is why the next step is known as authorization, right? So you can just look at the figure for an example. Recipient is verifying what are you allowed to do, right? So based on the request message, right, based on the SOAP message content, it will identify what that sender should be allowed to do. Okay, so once authenticated, recipient of a message may need to determine what requester is allowed to do. Okay, and this is called as authorization process. Fine. Now the question is, suppose you are having authorization for one service, right? Let me say that something like this. Okay, suppose you connected to account service, right? And account service has done the authorization and authentication both. Okay, now the point is, next time, or you can say after some time, after 10 minutes or after one day, you have to connect to the, let us say, notification service, right? Notification service, which is also with the accounts, or you can say it is both these services, account and notification are belonging to Railco, for example, right? So does the sender require to perform authentication authorization again? What do you think? Think in terms of SOA, right? Yes and no. What about others? Okay, Priyank is saying no as well. Okay, in terms of SOA, what we have is a loosely coupled architecture, if you remember, right? So services do not remember, right, what you are allowed to do. I think you will agree to that, Dev and Priyank. Yes, and due to that, what happens is we will have to force the requester to do authentication once again, right? But that is not going to be good, right, in terms of efficiency. Would you agree to that as well, right? So we need a solution, right? We'll see how this process is done actually, but I think the problem is clear, right? Due to loosely coupled architecture, every time the requester sends a message on the other side, it has to get authenticated, ideally, right? Because services do not remember. Because if services start to remember, you are going to violate one principle, which is that if services try to remember the things, right, which principle will get violated? I hope now you are in a position that you can at least decide the name of principle. Loose coupling, yes, definitely. But main thing over here is statelessness, right? Statelessness for the service will get violated, right? Priyank and Preet, I hope you agree. So we are actually violating statelessness as well as loose coupling, yes, right? But as statelessness is getting violated, that is why loose coupling will get violated. Are you getting the link? Right? Principles are related to each other. Yes. So this is going to be interesting. We are going to discuss the interrelation of principles in next chapter. We can do authorization in load balancer. Yes, yes, Dev. But is that load balancer is allowed? What is the goal of load balancer? Is it supposed to do authentication or authorization? Will it violate the reusability principle of load balancer then? If you embed the logic of authentication and authorization in load balancer, it will actually become specific. It is not going to be reusable anymore, right? It will reduce overhead, definitely, right? But rather than that, I would say, yes, Urjit, I'm coming to that point. Rather than that, I would suggest that you can have a special service that will perform authentication and authorization, right? Isn't it? Can't we do that? Dev and Urjit, I hope you're getting this idea, right? So it would be better to decouple the logic. See, if I embed the load balancing logic with authentication authorization, is that logic design appropriate? What do you think, Dev? We are embedding two different kinds of logic in a single service. Will that be proper as per service oriented principles? No, right? And that is why load balancer should not be given this job. Clear with that? And Urjit, I think you also agree to this, right? Okay. So that is why we need either a separate service, or what you can do is the first service that your requester sends the message to, right? For example, if the message was going to account service, right? If the message was going to account service, we will assign that job to the account service itself, right? It will do the authentication authorization, and then it will propagate that authentication information for other services or to other services. Seems logical, that approach? First point of contact can serve as authentication agent. I'll repeat. First point of contact can serve as authentication agent. No matter what that service is, account service, load balancer, or it may be your invoice service. Okay, that can be another design. Okay, so it depends how you design your architecture, right? Are you getting this second design, what I'm trying to say? Okay, I'll repeat. First point of contact means what, Urjit? You will be writing the address of the service where you are going, right? In the SOAP message, definitely. Yes. So can I say that that is going to be your first point of contact? Because your message is supposed to go to that service, let us say accounts, right? Okay. So if we let account service to do the authentication and authorization once, right? Once for all, I'm saying once for all. That means now after the authentication is done, yes, exactly. You are linking via header, and that is why no principle will be violated. I hope you are getting that, right? Everything is there in the SOAP message, right? That is what, and that is why I think now you are getting the idea why I was saying that SOAP messages are intelligence heavy, right? And self-sufficient, right? Those two terms are getting clear now, right? Okay, so this is one possibility, right? We'll see this in detail, how this actually works, okay? So are you clear with authorization process up to this, right? Identification, authentication, authorization, all of you are clear up to this, right? We'll see the process, right? How this actually works, okay? Now, look at this question. How can we propagate the authentication and authorization information for a service requester across multiple services behind initial service provider, right? If you remember that example, we had account service, we had the ledger service, right? We had notification service. There are so many services on the other side, okay? So ideally, whenever the requester connects to any other service except account, right, it should not have to do the authentication authorization once again. Do you agree with this? To have better performance, it should not have to repeat the process of authentication authorization, right? So that's what we mean by this. Behind initial service provider. Behind means what? Beyond account service, there are many services. So what if your requester is trying to contact them, right? So they should know that this requester is already authenticated, right? So we have a mechanism that ensures this. We'll see that solution very soon, right? And that is called as single sign-on, right? Single sign-on is a concept, remember? It is implemented by different programming platforms in different ways, right? Let us see what is single sign-on. The use of single sign-on allows a requester to be authenticated only once and then have its security context shared with other services, right? That the requester may access without further need of authentication. Okay. So like we were maintaining the context information in coordination framework, similarly over here, you have to embed a special header in the SOAP message, and that SOAP message should let the other services know that this service is already authenticated, right? It does not require re-authentication. Clear with the definition? And we call this as a security context. Is that fine? Right? Okay. So which are the practical implementations of this concept? Right. So it has been implemented in three ways by different vendors, you can say. The first is SAML. The full form is security assertion markup language. Like in XML, we have this another markup language that is specially designed for embedding, you can say, special identifiers, right, for security context. Microsoft has come up with another solution, .NET Passport. Anyone has explored this? Anyone knows about this? If no, you can explore that later, right? But .NET .NET Passport is one of the way by which you can do one-time authentication, right, in .NET applications. The last one is XACML, that is known as XML Access Control Markup Language. Okay. So again, these are designed by proprietary organizations and they have been accepted as standards. Okay. We are going to look at SAML because that is the most popular one, right? How SAML works. Are you clear with the basics? What is single sign-on? Right. So that we can go with the process of single sign-on in SAML. Are you clear up to this, all of you? Yes. Okay. Fine. So, okay, not getting the flow means not getting where the security context. Yes, I'll be clearing that because we are going to look at that process, Urjit. So you can wait for one more slide, right? We are going to look at the entire process, how security context is getting generated, how it is going to be shared. Like we have seen in the coordination framework. Remember that concept? There was an activation process that was generating the context and then it was being shared, right? Similar to that, SAML has a similar life cycle. We'll see that, right? Okay. So SAML implements single sign-on system in which the point of contact for a service requester can also act as an issuing authority. This is what I was telling you. The first service where you connect on the provider side can act as an issuing authority. Now, what do you mean by this term? What do you understand by this term, issuing authority? What do you think it should be doing? Yes, anyone? I think you can guess at least from the name. It is just like you're issuing a pass, right? To access the provider. Getting the concept at least? Yes, correct. It is like your activation service, right? Okay. Fine. So first point of contact, what does that mean? Suppose invoice service is sending the bill to the account service. I'll again repeat, invoice service is sending the bill to account service. So yes, load balancer is there in the path, right? But still we would say that first point of contact would be my account service because load balancer is just supposed to check the load on the server, right? It is not doing anything more useful. Are you getting this? So first point of contact would be your account service. Yes. Okay. Prince has agreed. What about others? Urjit, Priyank, Dev. I hope you are getting this, right? Yes. Okay. Okay. Not clear. Okay. I'll repeat. First point of contact means where actually you are destined to go. Invoice is supposed to go to account service. Yes, Urjit. So load balancer is there just to check the load on the server, but your ultimate goal is supposed to reach the account service. So that is why we would say that is the first point of contact for the requester. I hope now you are getting it, right? Yes. So that service will be working as issuing authority. So whatever it may be account service or service A or service B or service C, right? it has to perform authentication and authorization as per SAML standard. Are you all clear up to this? At least, right? The first service where you connect has to perform authentication authorization. Is that clear to all? First point. I'll also explain you this through a diagram, but I'm just going through the theory right now, right? Okay. This permits the underlying logic of that service not only to authenticate and authorize, but also to assure the other services that the requester has attained this level of clearance. That means it is just like if you have DDU ID, right? Can you can say enter all the premises of DDU, right? As a legal DDU student. Yes or no? It is just like that, right? I hope you are getting this example. Once your DDU ID is issued, can you access library or even the admin section or anywhere else, right? If the services are general, then we are not going to use this concept. Yes, Surjit. In that case, what you can do is you can delegate the task, right? Account service can, once it receives the message, it will delegate that job to some other service. It will perform the authentication authorization and then it will inform the account, right? We can do that, right? Delegation. Yes. But if it is a small scale architecture, we can let the account do this, right? So it depends upon how big your architecture is, right? Can we afford one more extra service? If yes, then we'll have a dedicated service to do this. Yes or no? Right? Because see, your requester does not know that a service exists on the other side for performing authentication. What it knows is I'm sending an invoice, okay? And I'm sending the invoice to the account service. Agreed to this? Okay. So account service has to decide that should I do the authentication or should I delegate that job to the other? Got it, right? So it depends upon how we are designing the architecture, right? Okay. Fine. So it is just like we are issuing an ID card to that service that now you are authorized and nobody else will ask you for re-authentication. That is the concept of SAML, right? Okay. Let us go for the process. Next step. Once the other services know that this service is already authenticated, the other services that the service requester contacts do not need to perform authentication authorization steps. So it is a one-time process. And that is why I think you are getting the name single sign-on. That is why it is called single sign-on. It is done only once. Clear with this concept at least? Yes? Okay. Instead, upon receiving a request, now see what the other service will do actually. Upon receiving a request from the requester, they will simply contact issuing authority to ask for authentication and authorization clearance, right? So it is like this. I'll give you a concrete example. Suppose you have an invoice service, right? Invoice is sending the message to accounts. Okay. So can I say that account service will be acting as issuing authority based on what we have seen? Yes, right? Now, suppose next invoice service is contacting notification service for getting updates, right? For getting updates, it wants to connect to notification service. Fine. So notification service, yes. Urjit has a question. When we are providing such layer in between the services, speed of response will reduce. Yes, so there is a trade-off, Urjit, we can say over here, but we have to enforce the loose coupling and statelessness, isn't it? Right? So you need capable hardware, that's what I can say, to handle all these things, right? And that's why implementing SO is not a simple thing, right? You need capable hardware that ensures that there will not be any latency, right? For exchanging so many messages, right? So yes, I agree to your point, but QoS can be improved by having scalable hardware, right? Okay. So I'll go back to the example. Suppose the invoice service is contacting notification. Now what notification will do? Can anyone tell me? Based on the second paragraph, what we have seen. Will notification ask for the authentication and authorization once again to the invoice service? No, right? Instead, where it will contact or where the notification service will contact? It will contact the issuing authority. And what is the issuing authority over here? Need to contact issuing authority? Yes, that's correct. What is the use of context? Yes, yes. So see, Priyank, basically the context will be generated and it will be shared as a SOAP header, right? So you are just asking that is this service authenticated? And in response, you will get the security context. Are you getting that situation? It is a request response MEP, right? Request is what? Asking that this particular requester is authenticated. In response, you will get the security context. And once you have security context with you, when that service contacts you once again, right? Do you have to ask the issuing authority now? Suppose after 5 minutes, if that service is requesting you once again, no, right? So that is why you need to preserve the security context. Clear? Yes? Okay. Again, we'll see the diagram, right, for this, but I'm just going through the theory so that you can easily read the diagram, right? Okay. The issuing authority provides this information in form of assertions, right? Assertion in the sense they are XML, you can say contents, right? Or basically you will be writing some XML logic or XML code, right? And that is actually your security context. Okay. And those assertions are embedded as a part of SOAP message. Those assertions are embedded as a part of SOAP message. Okay. And there are two types of assertions or XML headers possible. The first is authentication assertion. It tells you that this is authenticated service. And the second one is authorization assertion that proves that this is an authorized service, right? Now, let us look at this. Okay, so the requester is sending a SOAP request to service provider. We assume that there is no intermediary over here. Even if intermediary is there, then there is no issue, right? Okay. So service provider is your first point of contact. Can we say that? Let us say it is your account service, right? So it will act as issuing authority. And what issuing authority is supposed to do? Suppose if you are asked this question in MCQ or in theory, what is the task of issuing authority? Identify that. What will be the 2 or 3 tasks? Generate context, correct? Before that, in terms of functionality, what can we say? It has to perform authentication, it has to perform authorization, and then generate the context. Can I say that this is complete answer? Authentication, authorization, and context generation. Okay, these 3 things we have to do. So finally, once all these things are done, it will respond with a message that you are now authenticated and you can start communication, right? Then see what it is doing. Requester is accessing another provider on the other side, okay? And that provider has to do what now? It has to contact issuing authority with a request and see what request is having. Is this requester authenticated? Right? And the response will contain the security context and it will prove that it is authenticated. Clear with this diagram now? I think now you should not have any queries with this, right? That's why I explained you the concept first, right? So this is known as single sign-on process. Now, if you contact this provider once again, it will not even ask the issuing authority because it has already the security context available, right? So can we say that we have ensured that we are having loose coupling by doing all these things? Yes. One time you have to contact issuing authority, right? and then once you got the context, then you are done, right? So you do not have to repeat this process, right? So number of message exchanged between the requesters and providers would be reduced afterwards. Right? Initially, there will be a high amount of messages exchanged, right? But later on, it is not required. Okay. So this is all about single sign-on concept, right? So now I think even if you are asked this in theory, in external or in MCQ anywhere, what is single sign-on? How it works in SAML? Can you answer that in your own words, right? You can just remember this example and you can easily answer that, right? Again, remember this is an XML based standard, so it is accepted and used by multiple languages. Okay, fine. And as I said, you can explore .NET Passport as you already have studied .NET, and when in your free time you can explore how it ensures this single sign-on concept, right? In intermediary, do we have to generate the security context info there? No, actually, because see, if intermediary is supposed to do that, then the logic of intermediary would get violated. So I suggest you should not do that, right? Because SOA says that we want autonomy for the service, and intermediary services are always reusable in one sense. Yes, like load balancer. We have seen that, right? So we would not like to club extra logic with the reusable logic, right? Instead, I would suggest you go with a separate service that will do the authentication authorization, right? That would be a more clear solution, right? And you can say decoupled solution, yes? Okay, so this is SAML. Now we'll focus on the remaining concepts, confidentiality and integrity. We'll just touch upon this. We'll not go in detail. You already are studying the encryption and all those concepts in NIS, right? So the algorithms and everything you are going to study, right? I'll just explain you the concept. So confidentiality is nothing but protecting the privacy, right? So you can just have a look at the example. Recipient is asking that, has anyone unauthorized looked at this message since you sent it? Okay. So how it can ensure confidentiality, or how it can ensure that nobody has looked at that message, or at least nobody has accessed that message? By providing what? Encryption, right? Isn't it? You have to encrypt the message so that you ensure that nobody who is not having the proper key, right, should have a look at that message, right? So a message is considered to have remained confidential if no service or agent, remember, right? Web service is also called an agent, right? In its message path. What do you mean by message path? We have seen the definition, this definition, I think, in the first sessional phase. Message path can include all the services through which your message will pass on, right? So will it include intermediaries also? Message path includes intermediaries as well, yes or no? Obviously, yes, right? Because see, your message, I think you remember that point which I discussed during first sessional. The communication in SOA is not point to point. Instead, what did we describe that as? Point to star. Remember that concept? Yes, point to many, right? So depending upon the SOAP header information, your message will keep on navigating through multiple hops, and then finally it will reach the destination, right? So message path can be longer in case of SOA, right? So during the message path, we want to ensure that the message is not read by someone unauthorized, and that is called confidentiality. Fine. Next is integrity. Try to understand the difference by looking at the example. Has this message changed since you sent it? So we don't mind if someone has looked at it, but what we mind over here, or what we can't tolerate, not modified, right? Changes have not been done, right? So this is another level, right? Message can be open for reading, but we want to make sure that it is not modified. Okay. So let us look at the definition. Integrity ensures that a message has not been altered since its departure from the original sender. Okay. Why we are saying original sender? Because it can navigate through multiple, you can say, intermediaries, and every intermediary will be acting as a requester. Yes or no? Remember those roles, service roles. Every intermediary service will be acting as, you can say, a requester, right? So that's why, which term did we use for original sender? Anyone remembers that? There were 5 roles, right? Initial requester or initial sender? Yes, correct, right? Okay. So integrity guarantees that the state of the message contents remains intact, right? From the time of transmission to the point of delivery, right? There are 2 points, or you can say 2 nodes. Okay. These 2 also have to include other services, which is maintaining authentication and authorization. Yes, they may include, right? It depends upon how many services your message transits through, right? Yes, right? Okay. So between 2 poles, your message is going to go. One pole is your sender and the other is the recipient. Okay. So how do we ensure confidentiality and integrity? The answer to that is XML signature and XML encryption. I think we have covered that over here. Yes. Which slide it was? Yes. XML signature and XML encryption will ensure that we ensure the confidentiality and integrity, right? So before that, we need to look at one more point. Then we'll go for these 2 concepts. Yes, that is transport level security. All of you know SSL, right? What is the limitation of SSL? Anyone knows that? What is the limitation of secure socket layer with respect to SOA, right? It is doing a good job, SSL, right? But in case of SOA, it actually fails to some extent. Only secure HTTP request. Yes, correct, right? So I would go in further detail. The type of technology used to protect a message determines the extent to which the message remains protected. Fine. So which technology you use, right? That decides how much secure your message is going to be, right? If we rely totally on SSL, what happens is SSL secures the HTTP channel upon which the request and responses are transmitted. Obviously, your messages are going through the network, so they will be going through HTTP channel, and SSL will make sure that while the message is in transit, right? Mark my word, is it in transit? At that point only it is secured. But where it is not secured, there are 2 things we need to make sure regarding security in SOA. One is while it is transiting or while it is under transport, right? And when it is at intermediary service, isn't it? Right? So if you are relying only on SSL, it is only going to provide you transport level security. This figure will make you clear. Getting the idea what I'm trying to say? Yes? Can you see the protected boundary? Your message is protected only while it is under transit. But what if an imposter intermediary gets your message? Can it open it? It is not a proper intermediary. It is an imposter, right? So over there, your security would get violated. Agreed? So SSL fails over here. So only SSL is not sufficient. What we require now? Can you give me the solution? We have just seen that a few minutes ago. What is the easiest way to ensure that your message is protected even at intermediary service level, where it is written as not protected. Correct. Encrypt the message and append a digital signature that would add upon the security. Right. First thing is we have to encrypt it. Plus you embed a digital signature, because digital signature will make sure that the provider will be able to verify if the message has been modified or not. Right. If the signature is valid at the recipient end, then we can say that it is not modified. But if signature is not valid, then we can say that message has been compromised. Getting the idea? Yes. Okay, so SSL, I'll just summarize. SSL provides you transport level security, which is not sufficient for SOA based applications. You require transport level security as well as message level security. I hope this point is clear. Yes. So message level security can include the transport level security as well, right? And we have to ensure this by using encryption mechanism, right? Okay, so are you clear with this diagram now? If your message is encrypted, then it is protected throughout. Okay, fine. So for that, we have one standard, that is XML encryption. It is a technology designed for use with XML messages, right? It provides features with which encryption can be done either to an entire message or to only specific parts of the message, right? Ideally, would you be encrypting the entire message? Is there any point in encrypting the source address, destination address, and all those headers? No, right? If you are having B2B communication and you are storing the password to access that service, definitely you will be encrypting that part, right? That header that contains your password. Yes or no? But the other part does not have to be encrypted. Okay. So XML encryption is a customized standard, right? If you want to encrypt the entire message, that is also possible. If you want to encrypt only a part of that message, it is possible, right? Okay. Which are the two parts of the SOAP message? Anyone remembers that? Which are the two main parts of the SOAP message? Header and body, correct. So what this is saying is either you encrypt entire header portion, or you encrypt a specific header, or if you are storing confidential data in the body, then encrypt only body portion. Getting this, right? So it is completely customizable standard, right? The algorithm that will be used, that depends upon the algorithms that you are studying, right? Okay. Next is digital signature. It provides the feature that allow for XML document to be accompanied with a special information that is called as digital signature, right? How do we verify the digital signature? Let us look at that. Signature is tied to the contents of the document so that verification of the signature by the receiving service will only succeed if content has remained unaltered. So receiver will be doing verification. If verification returns with true, that means it is successful. Then we can say that the message is intact, not modified. If the verification fails, we can say that it has been modified. Got the concept? What is the use of digital signature? Right? Are you clear with the basics at least? Yes? Okay. So this is the example of this, right? What can be encrypted? As I said, either you can encrypt the entire header block, or individual header blocks can also be encrypted. As well as if you want some information in the body to be encrypted, that is also possible. And as an extra measure, you can embed a digital signature. Okay. So now I'll ask one question. If you want to ensure only confidentiality, which standard will be used? Only confidentiality. XML signature or XML encryption? Encryption. Correct. Right. But if you also want to ensure the integrity, then it requires signature as well. Got the concept? Yes. Right. So this is what is required, right? Because we are sending our message over the network, and whenever your SOA is involving banking kind of applications or accounting services, this kind of technologies have to be used. Okay, and that is why SAML and .NET Passport are popular, right? In that sense. Okay, so let us summarize this, and then we'll go for the next topic. Okay, security directly maps to the QoS. I think I don't need to explain this, right? Are you clear with that? If security is not there, quality is not there, right? So it directly relates with that, right? So it relates to only one characteristic of SOA, that is QoS, right? Let us look at the arrows which are given. Security protects the messages, obviously. Policies can implement security, right? So the business policy defined by your service decides whether you want to go for policy or not. Whether you want to go for security or not. I'll repeat. Business policy will decide whether you want security or not. I hope you agree with this, right? Okay. Then security prevents misuse of web services, obviously, right? So is this slide clear? What role security plays for service-oriented architecture? That is given over here. Okay. Security will improve the QoS. On the other hand, it is also affecting it. Yes, provided if you have poor hardware and non-scalable systems. Yes, but I hope and we assume that we have enough resources available, then it won't affect, right? Yes. Okay, so security is, so we have actually covered two very important specifications. In yesterday's class, we have seen the concept of this message exchange or metadata exchange. And today we have seen security. These both we have covered in the end, in the third session, because it required the previous concepts. You should know what is SOAP. You should know why SOAP message is intelligent. Right? Then only you can understand it. So I hope these points are clear, right? These two topics. Okay, now I'm going with the next topic, notification and eventing. Let us look at one interesting example. Service A is asking the service B, if something interesting happens, let me know. Service B is obliging that, okay, I will, right? And after a few moments, right? Service B is saying that, hey, something happened, right? So what kind of model you see over here? What is the observation based on this? Yes. Have you seen in this model anywhere? Correct. Absolutely correct. It is publish and subscribe, right? So publish and subscribe is actually a concept, right? It is not an implementation, right? So this has been implemented in two ways, right? So let us revise publish and subscribe in brief, then we'll go for the details. Publish and subscribe is a complex MEP. I hope you remember that. Which two MEPs we combined for this? Publish and subscribe. I'll simplify your answer. First is request response and second is one way, right? Or broadcast, right? It can be broadcast or multicast, depends upon your implement. Yes, Dave and Prince, that's correct, right? Okay. So it involves a publisher service that makes the information categorized by different topics, right? And you can only get the update if you are a subscriber, if you have registered, right? That kind of framework we have, okay? Subscribers can choose which topics they want to register for, either by interacting with the publisher directly, that's what we have seen in the publisher subscriber model, or you can also have a broker service in between, right? You must be aware of this stock broker systems, right? Or stock broker people. What is their goal? they take the request on the company's behalf, and they let you buy these stocks, right? So can I say that they are acting as intermediaries or agents, right? Can we have something like that in even publisher subscriber model? Like they will receive the request from subscriber, and they will forward that request to the publisher. So why we do this? So that we want to decouple the publisher and subscriber. We don't want them to connect directly. Yes, it might increase overhead. I think that might come to your mind. Yes, that might increase overhead in some sense, right? But if you are having too many subscribers, sometimes it is better to have decoupling between publisher and subscriber. Suppose you have 10,000 subscribers. Now a single publisher service might not be able to scale up to that. Are you getting this point? Right? So we will employ a separate service that is called a broker service, and that will be responsible for handling the requests and forwarding them to the publisher. We'll see this framework in detail. Okay, I'm going to explain this in detail. Are you getting the concept at least? Right? What is the purpose of a broker? Got the concept at least? Right? Okay. So, as I said, we have two frameworks for that. The first one is known as WS notification, and the second one is known as eventing. Right? Notification was designed by IBM. So IBM wanted that to be proprietary, right? Like apps through which we can yes, correct. Priyank, you can say that that is a good example, right? Correct. Another is WS eventing specification designed by Microsoft themselves. So Microsoft is using eventing for implementation of publisher subscriber, and IBM, wherever there are IBM solutions, they are using WS notification, right? So actually, this is the only point where we have proprietary standards. Generally in SOA, we don't have proprietary standards. They are global standards, right? But this is the only case where there is proprietary standard. Okay, got the concept? Yes. So both these frameworks are implementing the same concept that is known as publisher subscriber. Okay. So when a new piece of information on a given topic is available, publisher will broadcast that to the services that have subscribed. Okay. Alternatively, see, we have a role of broker as well. Broker service can be used to perform the broadcast on the publisher's behalf, right? So it is just like passing a parcel, right? Requester service is sending the request to broker, right? Broker is forwarding that to the publisher service, right? Whenever there is any update, right, the path will be reversed. Publisher service will send that to broker, right? And whenever the network is free, or let us say whenever the network is free of clutter, it will send it to the subscriber, or you can say the requester, following this paths, right? So by doing this, what we are able to achieve? Yes, you can say it is like CDN in one sense, yes, right? So what is the benefit of this? Having an additional service in between. There is a negative side as well, as I said earlier, right? We are involving one extra service, one extra pair of messages being exchanged. Yes, I agree to that. But in high volume environment, what is going to be the benefit? Can anyone tell me before we end? I'm not going to start with the concepts today or notification today. Yes, what is the benefit of this aspect? Okay, I'll show you the figure so that you can, yeah, this is like that. Can you see a broker in between? The other services we'll discuss, right, in detail in next class. But based on this, can you tell me the advantage? Less coupling and abstraction. Very good. These two are the points I wanted. Very nice. Thanks for the responses. Yes. So we are decoupling the publishers from directly being connected to the subscribers, right? So publishers can publish their notifications as and when they are free. Okay. But as soon as that notification is supposed to be sent, it will forward that notification to the broker, right? And immediately broker will send it to the subscriber. Are you getting the mechanism, right? And as Preet has written, we are having abstraction layer in between, right? So we are hiding the publisher from being exposed directly. Getting the concept at least? Yes, clear with the basics of this framework. So we are going to discuss this in detail in next class, right? What is WS notification and what is WS eventing? Okay. And then we can say that our chapter number 7 is complete. These are the last 2 topics. Okay. So thank you. Let us end the session for today. You have a great day ahead. Right?